So welcome to the learning series. This is where we're looking at the new basic uh, um, qualification exam from ISED, and the questions have changed effective July 15th, 2025. So we're going to be looking at section 4.1 to 4.6 today, which is basically electronics. And the new questions are in bold, and so we'll just go through them and see what comes up. Also, a reminder that there's now a study aid and a reference aid that you can take into the exam. It'll help you next week when we do electricity. So basically, there's a study aid that you can't take into the exam and a reference material which you can take into the exam. So the big difference here is that the study aid has words describing what it is. Oh, and they also have diagrams of different receivers and transmitters and installations. But the reference material doesn't have any words, just gives you the formulas and the diagrams, but nothing is labeled. And those you can bring into the exam. So we're almost halfway through. We've done a lot of the rules and regulations and the operations from a procedural point of view and from a technical point of view on the radio. Now we're starting to get into more of the components and the electronics and the electricity. And then we get into feed lines and antennas in section 6. And then 7 is propagation. And then 8 is interference. So in section 4, we talk about amplifiers, diodes, bipolar transistors, field effect transistors, the triode vacuum tube, and resistor color codes. So amplifiers. What term describes a circuit designed to increase the amplitude of a signal? So that's D, the answer is an amplifier. If an amplifier becomes nonlinear, the output signal would be. So when it becomes nonlinear, the signal becomes distorted. So D is the correct answer. To increase the level of a very weak radio signal from the antenna, you would use an RF amplifier. So you can either use an RF amplifier at the input of a receiver, or you can use an RF amplifier at the output of a transmitter, although the design is somewhat different. And if you're using it for a receiver, you're looking for the very low noise type of and low level amplification. While on the transmitter side, you want to increase the power, to tens or hundreds of watts, if not higher. To increase the level of very weak signals from a microphone, you would use. So in this case, you have a microphone. So the correct answer here would be an audio amplifier. What range of frequencies does speech amplifier of an amateur radio transceiver typically process? So this would be B, 300 hertz to 3000 hertz or 3 kilohertz. That's what's considered speech. Apart from power and current, which signal property can amplifiers specifically designed to increase? So power and current, if you think of Ohm's law, so what's left here is D, voltage. So you could increase voltage, you can amplify voltage, you can amplify current, or you can amplify the product of voltage and current, which is power. The increase in the signal level of an amplifier is called, so C, that would be known as gain. A device which gain has a property of, so again, gain is associated with an amplifier, so it's amplification. And if a device is labeled gain equals 10 dB, it's likely to be, Gain again is associated with an amplifier, and because this is a positive number, it would be an amplifier, B. Here is a new question. What term describes the ratio of output power to DC input power of an amplifier? And that would be known as the efficiency of an amplifier. So you measure the DC input coming into an amplifier, and you measure the power coming out of the amplifier, and that's known as efficiency. Another new question. What is the result of excessive positive feedback in an amplifier stage? So some of the output of the amplifier is feeding back into the input of the amplifier. So usually when that happens, oscillations start. So A is the correct answer. Oscillations appear. Now we get into diodes. So another new question for diodes. A diode in series in the positive power supply lead to a transceiver. What's its purpose? So in this case, it's put in there to protect reverse polarity protection. So if you hook up the power backwards, no current would flow. So it protects the transceiver. One important application for diodes is recovering information from transmitted signals. This is referred to as, and that would be A, detection. So remember, a diode can be used to demodulate AM modulated signals, and that's known as detection A. The primary purpose of a Zener diode is to So a Zener diode is to regulate or maintain a constant voltage. So B is the correct answer. The action of changing alternating current to direct current is called, and in this case, the answer would be D, rectification. So this would be in a power supply. The electrodes of a semiconductor diode is known as, that would be known as anode and cathode. If an alternating current is applied to the anode of a diode, what would you expect to see at the cathode? So in this case, it's used as a rectifier. So at the output of the diode, you would see pulsating direct current. In a semiconductor diode, electrons flow from the cathode to the anode. What semiconductor device glows different colors depending on its chemical composition? This would be a special form of diode, and it's known as a light emitting diode or LED. Which property of a semiconductor diode permits its use for reverse polarity protection? So that would be C. It conducts in one direction only. In order for a diode to conduct, it must be D, forward biased. If it's reverse biased, it doesn't conduct any current or a minimal amount of current. Most of the current would be traveling if it's forward biased. Now we get into bipolar transistors. So which of these components can amplify a small signal using low voltages? So in this case, the only one that makes sense would be a bipolar transistor, B. What term describes the most basic semiconductor component used to amplify? So the key here is used to amplify. So that would be B, transistor. What are the three electrodes of a bipolar transistor? So remembering EBC or collector emitter base. A is the correct answer. If a low-level signal is placed at the input of a transistor and the high level of signal is produced at the output, what is this effect called? So this would be an amplifier. So C, amplification is the correct answer. Here is a new question. What prevents the substitution of a PNP transistor with an NPN transistor? So basically, because this is positive, negative, positive, and this is negative, positive, negative, the polarities are reversed. So C would be the correct answer. A semiconductor device is labeled as a general purpose audio NPN device. What is it? So in this case, it would be a B, a bipolar transistor. What are the two basic types of bipolar transistors? And that would be an NPN and a PNP transistor. Which of these operating conditions is most likely to cause a transistor to fail? So if with semiconductors, if they get too hot and carry too much current, um, it destroys them. So excessive heat is the problem. Here is a new question. Which electrode of a bipolar transistor controls the output current? So you have EBC, so source is definitely the wrong answer. And because the base controls the current, so C is the correct answer, base. Also, in these sections we're covering, there used to be a lot of comparisons between various devices. Those questions have been eliminated. So there's only a few questions now comparing devices. Another new question is when a bipolar transistor is used as a switch, which electrode controls its state? So in this case, it would be the base again. The base is either the input to the amplifier or the input to a switch. If a transistor is alternatively driven into saturation and cutoff, what does it behave like? So this is a new question, and that would be D. It would be a switch. So in one case, it would be off, and in another case, it would be on. So D is the correct answer, a switch. Now we get into another type of transistor known as the field effect transistor, or FET, or MOSFET. When considering the material between the source and the drain, what are the two basic types of field effect transistors? So in this case, field effect transistors are N-channel and P-channel. What semiconductor device has a gate, a drain, and a source? That would be a field effect transistor. In a field effect transistor, which electrode controls the resistance of a device channel? So in this case, that would be B, the gate. In a field effect transistor, from which electrodes do charge carriers enter the channel? So that would come from the source, B. In a field effect transistor, from which electrode do charge carriers leave the channel? So we talked about the gate, we talked about the source. So the thing that's left is C, is the drain. Remember that D, the collector, refers to a bipolar transistor, not to a field effect transistor. Here's a new question. Why is the field effect transistor considered a high impedance device? And that's because the gate never conducts current. So it turns things on and off without using current. It's based on voltage rather than current. What is the control electrode in a field effect transistor? And that would be D, the gate. In a field effect transistor, what circuit parameter causes the change to the okay, let me rephrase this. In a field effect transistor, what circuit parameter causes the current to increase? And that would be if you decrease the reverse bias, the current goes up. So D is the correct answer. Which electrode of a bipolar transistor component corresponds to the source of a field effect transistor? So here's one of the examples where they're comparing a bipolar transistor to the source of a field effect transistor. So in this case, it would be the emitter. Which electrode of a bipolar transistor corresponds to the drain of a field effect transistor? So the drain it corresponds to the collector of a bipolar transistor. In a field effect transistor, which two electrodes are connected to the ends of the channel? So the ends of the channel would be the source and the drain. Now we get into vacuum tubes and we talk about the triode vacuum tube, which is one reason a triode vacuum tube might be used instead of a transistor in a circuit. And generally, a vacuum tube may be able to handle higher power. So D is the correct answer. Here's a new question. Which two elements of a triode carry the output current? So here it's the cathode and the plate. A feature common to triode tubes and transistors is that both of these are used to amplify as an amplifier. So B is the correct answer, can amplify signals. Which electrode of a vacuum tube is operated with the highest positive voltage? So that would be the plate, or a plate or the anode. And that's because you want the electrons to go from the cathode over to the plate or the anode. So you need to charge it with a high positive voltage. Which semiconductor device has characteristics most similar to a triode vacuum tube? So in this case, both operate similarly. That would be C, the field effect transistor, because they both have a high impedance input and they work on voltages while the bipolar transistor works on current. A new question. Which electrode of the vacuum triode is the control element? And that would be the grid. So the grid is between the cathode and the plate, and it controls the amount of electrons getting through. In the vacuum tube, which electrodes emits electrons? And that would be the cathode. What is inside the envelope of a triode tube? So in this case, because electrons are traveling in it, you want a vacuum. So B is the correct answer. What term describes a vacuum tube with a cathode, a single grid, and a plate? So think of it as three. And so that would be a triode. B is the correct answer. Now we get into resistor color codes. So generally, resistors have 4 color bands. So the last band or the fourth band is usually the tolerance. So C is the correct answer. On a resistor with 4 color bands, what do the first 3 color bands indicate? So that would be the value of the resistor in ohms. So B is the correct answer. On a resistor with 4 color bands, what does the fourth color band indicate? So we already covered that in the first question. So it's B, the resistance tolerance in percent. Here's a question. What are the possible values of a 100 ohm resistor with a 10% tolerance? So that means it's 100 ohms plus or minus 10%. So if you work out the math, that would be 90 ohms to 110 ohms. So B would be the correct answer. So on resistors with 4 color bands, which color band differentiates two resistors rated at 33 ohms and 39 ohms? So if you look at that, so the first band would give you the 3, and the second band would determine whether it's a 3 or a 9. So the correct answer is the second band. Out of the list of resistor tolerances below, what has the highest precision? So in this case, it would be the lowest tolerance. So A would be the correct one, 0.1%. Out of the list of resistors below, which has the lowest precision? So this means the highest tolerance. So that would be D, 20%. What does the resistance of a resistor change with rising ambient temperature? So it really depends on the temperature coefficient of the resistor. So B is the correct answer. Depending on the design of the resistor, it may go up in value or it may go down in value. So B is the correct answer. Here's a new question. Which resistor rating is specified as given fraction per degree Celsius? So this is known as the temperature coefficient of the resistor. So C is the correct answer. On the resistors with 4 color bands, which color band differentiates two resistors rated at 120 ohms and 1200 ohms? So that would be the fourth band, because the third band. So that's the third band. The third band would be the multiplier. So that one would be the first band, 2 would be the second band, and the third band would be the multiplier. So it would be either a multiplier of 10 or 100. So given that the resistor values are red is 2, violet is 7, and yellow is 4, what is the nominal value of a resistor whose color code reads red, violet, and yellow? So red would be 2, 7 would be violet, so that would be 7. So, and then the last one, yellow, is the multiplier. So yellow would be 10 to the fourth or 10,000. So you take 27 times 10,000. So it would give you 270 kilo ohms, which would be B, is the correct answer. And so that concludes the section on electronics. So next week, we'll look at electricity components and measurements. And this is when we talk about the metric system, about Ohm's law, power, resistors, inductors, and capacitors in series and in parallel. And then we get into frequency, decibels, transformers. Transformers is a relatively new section. Talk a little bit about resonance and impedance and reactance and meters and measurement. So that's coming up next week. Well, let me just stop the recording here.